Welcome to The Explainer. Today, we're going on a heck of a journey. We're going to connect the dots from something as simple as a calculation all the way to the very fabric of reality itself. And in the process, we're going to challenge a really common idea about our place in the universe, and maybe, just maybe, uncover what makes us cosmically significant.
You've probably heard this quote from Stephen Hawking before. It sums up the principle of mediocrity perfectly. It's this idea that, in the grand cosmic scheme of things, there's nothing really special about us. We're just an accident, a bit of chemical scum on a boring rock floating through a universe that doesn't care.
But what if that whole view is just fundamentally wrong? What if our ability to actually understand the universe, to create knowledge, doesn't just make us interesting, but makes us profoundly important? That's the big, powerful counter-argument we're digging into today.
So, to build this case, let's start with a comparison you hear all the time. The brain is a computer. And it's easy to just dismiss that, right? It sounds like just the latest metaphor. I mean, we used to say the brain was like a steam engine or a telephone switchboard, but what if the computer comparison is totally different?
It is. It's fundamentally different. A steam engine, as you can see, is a specific machine built for a specific job. A universal computer, though, that's a whole other category of thing. In principle, it can simulate any physical process that the laws of physics allow. It's not just one more tool. It's a machine that has the potential to become every other tool.
This idea of universality, it's a really, really big deal. It represents this incredible leap from being limited to being, well, infinite in your reach. And if you look back through human history, you can actually see our systems of knowledge making this exact same jump over and over again.
Just take computation itself. We started out with super simple stuff like tally marks. Then you get Roman numerals, which had rules, but they were incredibly clumsy for anything complicated. Babbage's engines in the 1800s were amazing, but they were still special-purpose calculators. The real jump, the jump to universality, was a conceptual one. Alan Turing's vision of a universal machine, a single theoretical device that could compute anything that is computable.
Okay, now for a really critical turn in our story. This is where the abstract idea of a universal machine smashes right into the physical world. It's where computation shows us what it's really made of.
This brings us to a really profound idea called the Turing Principle. It states that everything not forbidden by the laws of nature
Is achievable, given the right knowledge. Now, this isn't just some feel-good motivational poster. It's presented as a fundamental law of physics. It means that any physical transformation you can think of, from turning lead into gold to building a starship, is possible, as long as we know how to do it.
So, the key takeaway here is that computation isn't just abstract math floating around in space. It is a physical process. The limits of what we can compute are set by the laws of physics themselves. A universal computer, then, is a machine that can actually harness those laws to make any achievable transformation happen. It's the physical bridge between knowledge and reality.
And this physical view of computation, it leads us straight to the real challenge of artificial intelligence. So much of the conversation around AGI, artificial general intelligence, is all about processing power and speed. But if this theory holds up, the real test isn't about speed at all. It's about creativity.
To really get a handle on this, we need to understand the difference between just knowing facts and actually understanding them. Real understanding comes from what's called explanatory knowledge. It's not just about predicting an outcome, it's about explaining why it happens. And you know you have a good explanation when it's hard to vary. If you change any important detail, the whole thing just falls apart. That's how you know it's solid.
But is that actually true? There's a pretty popular view in science called instrumentalism. And it argues that, hey, the only thing that really matters is being able to make accurate predictions. But just think about it. Imagine you had a perfect oracle, a crystal ball that could predict the outcome of any experiment. It could tell you, yep, that new spaceship design will fail. But it could never tell you why. Without an explanation, you don't know how to fix it, or how to improve it, or how to build a better one next time. Prediction, in the end, is no substitute for explanation. So this brings us to the real acid test for AGI. It isn't about passing the Turing test, just fooling a human in a chat. The ultimate question is this: can a machine be genuinely creative? Can it generate brand new, hard-to-vary explanations about the world? That is the great unsolved problem at the very heart of AI research.
All right, let's tie all these threads together now. Universality, explanation, and computation, and connect them to the deepest level of physics. This is where the whole argument comes full circle and points toward our ultimate place in the cosmos.
To really grasp the ultimate physical limits of what can be computed, we have to leave the classical world behind us. We have to go quantum. You see, quantum computers aren't just faster versions of your laptop. They are a fundamentally new kind of machine that operates on a completely different layer of reality. A layer that, according to one major interpretation, includes a vast multiverse of parallel universes. This number, it's just staggering. It gives you a sense of the scale we're talking about. To solve certain problems that would take a classical computer longer than the age of the universe, a quantum computer is effectively running computations in parallel. In this view, it's leveraging the resources of roughly 10 to the 500 other universes to find the single right answer. It's computation on a multiversal scale. And this leads to a completely mind-blowing conclusion. In this physical picture of the world, knowledge isn't just an abstract idea. It is a physical thing, with a distinct structure across the multiverse. Think of a well-adapted gene in our DNA. In our universe, it might look like one of many random possibilities. But across the multiverse, it actually has a regular, almost crystal-like structure, because most of the other tiny variations just wouldn't work. They wouldn't create an animal that could survive. That physical structure, that is the signature of knowledge. So here, then, is our ultimate significance, an entity that's capable of creating explanatory knowledge. A person, or maybe a future AGI, is more than a universal computer. It's a universal explainer. And if knowledge is a physically real part of the multiverse's fabric, then the creators of that knowledge, well, we aren't just chemical scum. We are the agents of cosmic creation, taking part in an infinite, open-ended process of discovery.
And this leaves us with one final, incredibly powerful idea, the principle of optimism. It suggests that all evils, all of our problems, are simply the result of not having enough knowledge yet. And if that's true, then no problem is fundamentally unsolvable. It means we're never at the end of progress. We are always at what the physicist David Deutsch calls the beginning of infinity. The question is not if we can solve our problems, but which problems we're going to choose to solve next.